Number one, I'm going to start with answering these questions, then I'm going to go back and write the piecewise. So let's start. Domain is which axis? It is the x-axis. Great. So that is wall to wall. Can I put a wall up here? No. Can I put a wall up here? No. Therefore, it's all real numbers. Excellent. You could have also done negative infinity to infinity. That is acceptable. Please remember there's multiple acceptable answers because you guys had different ways that your teachers taught you to write that. Question. If it's a closed, yes. So that's a good point. If there's an actual number, let's say that just this was our graph. My domain would be 0 to infinity, and the 0 would get a square bracket because this is closed. If it was an open circle, it would get the parenthesis. Does that help you? Okay. All right, range. Okay, this is going to keep going and going and going. So do I have a floor? Do I have a ceiling? So it's going to be all real numbers. But somebody go, oh, there's a hole there, but that hole got filled here and here. Yes? Okay, so my range is all real numbers. Now, what I'm about to show you is not necessary, but you can do it if you'd like. I labeled a picture. So this is decreasing, increasing, decreasing. For increasing, decreasing, I use the range. My range starts with negative infinity and ends with infinity. That's what all reals are. So from negative infinity up to what value is it decreasing? Negative 5. So from negative infinity to negative 5, it's decreasing. And from where to where? What's this? 0 to infinity. Great. Okay, so this is my increasing. Where did it start increasing? Negative 5 up to 0. Are we good? No. What's your question? Decreasing? So, from negative infinity to negative 5, it's decreasing. Start, stop. You need a start and a stop. Here, it starts at the x value, okay? The x value here is 0. The x value here is infinity. The x value, not the y. For this point here, right, it's positive infinity, comma, negative infinity. Okay? X value, not the Y value. You guys get in a habit of looking at where the arrow is pointing. I'll get to it in a second. Okay? Was that the end of the questions? All right. F of 0 is going to be what value? All right. Why is it 4 and not negative 1? Because it's closed circle at 4. Excellent. Good job. Okay? All right, now for the hardest part, writing the piecewise. All of these are what type of functions? Linear. So they're going to follow the format y equals mx plus b, where m is the slope and b is the y-intercept. I'm actually going to start with this line here only because why? Why am I starting with that one? I think that's the easiest one up there. Why is it the easiest one? But what else is simple? I already have the y-intercept. Thank you, sir. I already have the y-intercept. So this one here, what's my y-intercept? So plus 4. Building my triangle. All right, so I'm going to build my triangle there and there, okay? Now, if you're having difficulty, I would build your triangle from the start to the end. It works perfectly every time. If you can't find a good spot, remember a good spot is where the line hits a grid intersection, okay? So my height is 2, my width is 3. So 2/3 x, positive or negative? Negative, because it's going downhill. And the restriction is x greater than or equal to 0. Okay, we good? All right, the next one is this increasing section is super easy because, again, it has the y-intercept. Okay? So, this equation is going to be, what's my y-intercept? -1. So what I was talking about before is if you have trouble picking good points, just do start and end. So how tall is it? 1, 2, 3, 4 tall. 1, 2, 3, 4, 5 wide. So that's going to be 4 over 5x. Positive or negative? Y. If I cover up the endpoints, it's going uphill, correct? It is only this equation from where to where? Where did it start? -5 until 0. X is sandwiched between. This got an underline because this is a filled circle. Okay? Are we good? All right. Last line is tricky. So the last line is going to be, if I build my triangle and do my slope, it ends up being 4 over 2, which is 2x, -2x, okay? Unfortunately, if I try to continue the pattern, there is no room on the grid. So you have to pick a good point. So I'm going to pick this point right here, which happens to be 1, 2, 3, 4, 5, 6, 7, a -7, -1. So when I plug it in, what's -2 times -7? It is 14. So then I end up with 14 equals, 14 plus b equals -1. Therefore, b equals what? -15. So that is my equation for that one. So that's a -15. And then my restriction is x less than 5. Are we good? Are we okay with that? Okay, thank you. All right, so 1, 2, 3, 4, 5, 6, 7. Yep, okay. All right, okay? Yes. Okay, so I took the equation. Y equals mx plus b. I already knew the slope was -2. Are you okay with that? Because when I built my triangle, it was 4 high by 2 wide. Let me show you my triangle. There's my triangle. It's 4 by 2. So 4 divided by 2 is 2. Remember, it's height over width, y over x. Okay, so then I picked a point. This point here is the ordered pair -7, -1. You okay with that? It has to be a good point. See, like here, that's not a good point. But this is a point that I can give the exact address for. Yes? And it touches the line that's graphed. Agree? Okay, so then I plug it in. So I'm going to multiply this by -7 because that's what x is. And this is -1 plus b. So then I end up with -1 equals 14 plus b because -2 times -7 is positive 14. I subtract 14 from both sides and I get -15. Everyone okay with that? Okay? And that's if I can't extend the line to actually, ideally, if you can do the pattern and touch the line, you're better off so that you don't make a mistake in the algebra. Okay? But this particular one, if I move down over 1, down 2 over 1, down 2 over 1, and I kept going, I run out of grid. Okay? Good? All right. Problem number 2. Okay, so if they want me to graph, the safest way to always graph is, what's the safest way to graph? What do I need to do? Table of values. Now, you will notice that this does not equal 0, but that doesn't matter. 0 still has to be part of my table because it's in the restriction. So I'm going to pick 0 and numbers smaller or bigger? Smaller. So I'm going to go -1, -2, -3, -4. I'm going to do a couple, and you'll see my reason why in a second, okay? All right, so what's 0 squared? What's 6 times 0? And 0 plus 0 is? 0. And then add on the 4, I get 4. What's -1 squared? What's 6 times negative 1? So 1 plus negative 6 is negative 5, plus 4 is negative 1. Great. When I square negative 2, I get 4. 4 minus 12 is negative 8, plus 4 is negative 4. When I do 3, it's 9 minus 18, which is negative 9, plus 4 is negative 5. When I do negative 4, it's 16 minus 24, which is negative 8, plus 4 is back to a negative 4. Cool? Yes, question. So now I'm going to plot these points. Open or close circle? Open at 0, 4. Open circle. Negative 1, negative 1. Negative 2, negative 4. Negative 3, negative 5, and then back here. And I know this is correct because it's squared, so it should make a parabola. And it should loop back up because it is positive. So that was the hardest part of the entire problem. Now, next one. I am also going to include 0. Notice they both have 0. They both start with 0. Bigger or smaller? Bigger. All right, now, here's the trick. Whenever your slope is a fraction, you always want to pick multiples of the denominator. So what's a multiple of 3? Another multiple of 3. Great. All right, 2 to 3 points is enough for a linear equation. So negative 2/3 times 0 plus 4 is 4. 3 divided by 3. 1. Thank you. 1 times negative 2 is negative 2. Plus 4 is 2. 6 divided by 3. 2 times negative 2. Negative 4 plus 4 is 0. I'm going to go ahead and plot these points. So, 0, 4, it overlaps. And then 3, 2. And then 6, 0. And I should have a linear function. This problem is done. A-okay? Yes, question. How do you get the table for the first one? You always take the value of the restriction and then follow it. So 0 and numbers smaller. So I have to pick numbers smaller. Okay? Good? All right, moving on. Question number 3. Okay, so number 3 is my function notation items. So question A is asking me to do what? What's question A asking me to do? Plug in 2 for x in which function? F. So I'm going to do 1 over 2 and la-di-da, I am done. All right, so the next lovely one. I'm going to start with 14 in which function? G. So I'm going to do the square root of 14 plus 2, which is the square root of 16, which is 4. I only take positive 4 because the square root was already in the problem. I didn't put it in the problem. Are we good? Now I'm going to plug this into the f function. So 1 over 4 is my final answer. Cool? For B. Okay? Final one. The final one is 1 over x divided by x squared plus 1. Okay? I wrote it out this way so you can see the reason. Now, copy, change, flip. So the reciprocal of this is 1 over x squared plus 1. Because remember, when you divide fractions, you really multiply by the reciprocal. So 1 times 1, 1. X times x squared, x times 1, x. Problem done. Remember, when dealing with fractions and division, you multiply by the reciprocal. The reciprocal is just flipping the fraction. So if I had 2/3, the reciprocal would be 3/2. A-okay? All right, moving on. Yes. You can always watch the replay so I can get all the answers. Thank you. All right, our favorite composition of functions to test inverse. That means I have to do f of g and g of f. Here we go. So, f of g, I'm going to take g and I'm going to plug it into f. So, 3 times 1/3 x minus 7 plus 7. Distribute, distribute. Okay? So this is x minus 21 plus 7, which is x minus 14. A-okay? All right. Now I'm going to do g of f of x, which means I'm going to take function f and plug it into g. So I'm going to do 1/3 of 3x plus 7 minus 7. I'm going to use distributive property. I get x plus 7/3 minus 7. I'm stopping because I know 7/3 minus 7 is not going to give me negative 14. Therefore, they are not inverses. They are not inverses. A-okay? Question. So, whenever you are testing inverses, you have to do f of g and g of f. That is the rule for testing functions using composition. So the answer are, this first problem up here, problem A, they are not inverses. So that the final answer does not match, they are not inverses. Okay, let me do the next example. All right, so same thing. I'm going to take G and I'm going to plug it into F. So 1 plus the square root of x minus 1 squared. Okay, what can I do? The square root and the squared cancel each other. So 1 plus x minus 1. What cancels? The 1's, and I'm left with just x. Now I'm going to take f and plug it into g. So instead of writing x, what am I going to write? 1 plus the square root of x minus 1 squared. What can I do first? What can I cancel? No, you cannot. The 1's. You cannot cancel the squared and the square root because they're not alone. This 1 cancels this. I'm left with the square root of x squared. Now a squared cancels the square root, and I'm left with just x. Therefore, are they inverses? Why? Because they're the same. Yes, because f of g equals g of f. I'm okay with yes. I'm getting into this because this is required for AP calculus exam. You can't just stop at yes. So I'm trying, a lot of times when I emphasize and go into more detail that's preparing you for calculus is not required. Okay? Okay, this one, my favorite, limits. My first wall is going to go up at what value? Negative 4. There's the wall. Okay, positive is the right-hand side. The right-hand side has a height of negative 0.5. Because, guys, this is negative 2. So each of these is a half. Yes? Okay. The left-hand side hits at a height of, are they in agreement? So the limit does not exist. Okay? What is f at negative 4? Why did you choose 0 and not negative 0.5? Because that's a closed circle. Okay, now I'm moving on to 0. Bam, there's 0. The right-hand side has a height of negative 4. The left-hand side, 0.5. Do they agree? No. What is the value at 0? Negative 4. Because that's the closed circle. All right, final one. 2. The right-hand side touches at a height of 3. The left-hand side, does the limit exist? Does the function of 2 exist? It is 0. Nice job, because that's a closed circle. Okay? Yes. Plus means the right-hand side of the fence. Negative means the left-hand side. This is negative 4, right-hand side. This is negative 4, left-hand side. In order to do at exactly negative 4, you have to do right and left. If right and left agree, the limit exists. If they disagree, it does not. Okay, here we go. Woo! All right, we're going to start with B because it's the easiest. What rule applies to square roots? What do you know about square roots? What rule goes with square roots? What can't you do? You can't take the square root of a negative, which means that 16 minus x squared has to be greater than or equal to 0, yes? The two major rules. We discussed the two major rules, right? It can't be negative. Do you have to do it algebraically? No, you could have thought and processed through it. All right, so algebraic to me is easier though. So 16 is greater than or equal to x squared, yes? But when I move it to the other side, it becomes positive. Okay, now I'm going to take the square root. Because I am taking the square root, I have to take the If I take the square root, I have to take I need the positive and the negative. Okay? So x has to be between what two values? Negative 4 and positive 4. What happens if I choose 5? What's 5 squared? 25, right? So 16 minus 25 is 9. So it would give me it would be negative 9, right? So that's the other way you could have done it, is test it in your head. Because it's between negative 4. So this is saying x is bigger than negative 4 but smaller than 4. It's between negative 4 and 4. Nathan. Okay. What rule applies here? What rule? There are 3 major rules. We only practice 2. Come on, this one you learned as a little kid. I'm dealing with a fraction. I'm dealing with a fraction. What can't happen? What can't happen in a fraction? The denominator can't equal 0. So x squared plus x minus 2 can't equal 0. Yes? No 0 in the denominator. How do I solve an x squared? How do you solve x squared? No. Thank you. Factoring. This is an easy factoring because the lead coefficient is 1. So what are two numbers that multiply to negative 2 and add up to 1? Negative 1 and 2. So I have x plus 2, x minus 1. Yes? Okay. So x plus 2 equals 0, negative 2. X minus 1 equals 0, x equals 1. So what are the two answers x cannot be? What are the two answers x cannot be? Negative 2 and 1. So all reals except negative 2 and 1. I almost flipped the sign. Sorry. Cool? All right. So what are the two major rules, since you guys forgot them and we haven't talked about them since week 1? You can't divide by 0 and you can't have a square root of a negative. Can you have a cubic root of a negative? Yes. Good job. All right. Moving on. This is number 7. We have not done number 7. But number 7 is ridiculously easy. Are you ready? All right. You are going to take all your x's and you're going to replace them with negative x. So negative x squared minus 9 When I simplify is x squared minus 9. What do you notice? What do you notice? They're the same. We call that even Steven. Even Steven. They stayed the same. So this is an even function. If when you replace x with negative x, it stays the same, it is an even function. Even Steven. That's how I remember it. All right, so let's look at this next one. Negative x cubed minus 2 times negative x plus 9. Negative x cubed plus 2x plus 9. What do you notice? It's not even Steven. Okay, what if I covered this up? What do you notice? Let's pretend this wasn't here and this wasn't here. What do you notice? From the beginning to the end. Look at the beginning, look at the end. What do you notice? Everything did what? No, they're not the same. It flipped. If everything is opposite, it's odd. Okay, now, if everything is opposite, let's look at our problem. Is everything opposite? No, because 9 stayed the same. So this is neither. So, because that's how we test even or odd. We replace x with negative x. That's how you test for even or odd algebraically. Okay? So, if when I replace x with negative x and do the math again, it's the same, it's even. If everyone switches signs, it's odd. If some switch and some don't, it is neither. Neither, neither, nor. All right. Number 8 is the easiest one in the world. I hope you didn't miss it. Well, I guess it's number 9 on your packet because I skipped 8. All right, ready? Here we go. Let's start with this is a max. This is a min. This is a local max. This is a local max. And this is a local min. Everyone okay with that? All right, moving on. Again, if it does not have endpoints, it's assumed to have arrows. So what's my domain? All real numbers. My range is y greater than or equal to? What's the lowest value for y? 0. Do I know the max or the min? Or both? Which one do I know? Max or min on this picture? I know the min, therefore it's bounded below. Okay, is this increasing, decreasing, or both? Increasing, which makes my life easy because increasing, decreasing goes with the domain. And since it's increasing the whole time, it's all reals, and there is no decreasing. None. Okay, easy peasy, lemon squeezy. Awesome. Ready? Moving on. Okay, this one requires some think. No, it doesn't. Okay, so left-hand side, is that less than or greater than? Left-hand side of the number line, less than. So I'm going to go with this top equation because it says less than. So I'm going to do 2 times negative 1 squared plus 3, which is 2 times 1 plus 3, which equals 5. A-okay? Okay. I deleted the equal to on yours. Delete the equal to on your packet. Sorry. Now for this one, it's 3 minus 2 times a negative 1, which is 3 plus 2, which is 5. What's the limit? 5. Okay, so if the left and the right met up, what type of discontinuity would that be? It is removable. What happens if the left had been 4 and the right had been 2? What type of discontinuity is that? Jump. What if one of the limits I couldn't figure out because it made a 0 in the bottom? That's my infinity, okay? That's my infinity. That's my infinity. If I can't solve it, that's my infinity ones. Infinity ones, yeah. There's 3 types of discontinuity: removable, jump, infinite. Yep, okay, cool. We're here. Yes? The easiest one is this. Give me 2 numbers that multiply to 10 and add up to 7. Oh, x plus 2, x plus 5. Great. The next easy one is this one, because I'm going to do the same thing. So, 3 times 4, 12. So it needs to multiply to 12 and add up to negative 8. What are 2 numbers that multiply to 12 and add up to negative 8? Oh, that was not nice. 6 and 2. X minus 6, x minus 2. Am I done? Why not? That lead coefficient, this guy has to go here and here. Can I do 6 divided by 3?
Yes.
What is it?
X minus 2.
Okay, can I do 2 divided by 3? No, so this guy goes out front. Shortcut factoring. Boom, done. Now, this is my other favorite one. This one actually is super easy too because it's perfect squares. So I can only do this when it's perfect square minus perfect square. What's the square root of x squared?
9.
What is the square root of x? What's the square root of 81? 9 and? So we have x plus 9 and x minus 9. Cool? Now this problem should have come before number 6 because that's where you use the factoring. Cool? Again, your review packet is a way longer than your test. Okay, I'm going to come back to this because we need to pull up the graphing calculator. Okay, number 14 we did, but let's go over it again. I have a hot cup of coffee. It started at 90 degrees. It cooled down to 74 degrees. At some point, was it 80 degrees?
Yes.
Why?
Because it has to pass through.
It has to pass through 80 on the way from 90 to 74. Pass 80 when going from 90 to 74. A-okay? Easy peasy, lemon squeezy. All right, moving on. I forget, but it's a heck of a lot less than your review. I think it's 10. All right, so if a function is continuous, the left and the right must collide. They must touch. Excellent. So which equation do I know the most information about, the top one or the bottom one? Top. Great. What do I want x to be? What do I want x to be? 3. So I'm going to do 3 squared minus 5, which is 9 minus 5, which is 4. Which means the bottom, if they collide, the bottom also must be 4. So I have 4x plus h equals 4. Well, hold up. What did we say x was going to be? What did we say x was going to be? 3. So 4 times 3 plus h equals 4. Because we're being consistent. My x is 3 in both of them, yes? And I know that because they told me up here. Okay, so now let's keep solving. 12 plus h equals 4. Therefore, h equals negative 8. Subtract 12 from both sides. I didn't show my work. Are we okay with that? All right, cool. Last problem before I go to graphing. Okay, the last problem. What do you notice that they both have? What do they both have?
X plus 9.
X plus 9. So I'm going to go ahead and make that my g. So g of x equals x plus 9. Okay, rewrite the function without the x plus 9. What is it? 6x cubed minus sine x plus 3. Done. G of x should always be what is repeated. Okay? All right. Let me pull up the graphing calculator really fast. And I don't remember because I'm on a different computer. If it's loaded on this computer, it may not be. It is. Yay. Okay. I'm going to go through this super fast. Sorry, because we're like getting ready for the bell to ring. All right. So we are on number 13 and then we're done. I will have graphing calculators for you tomorrow if you don't have your own, but here we go. Yes. On Monday, I mean. I know. Sorry. Okay. Okay, so I'm going to go to y equals, and I'm going to type, what's the first equation? 2 natural log x. I'm going to hit graph. Okay? All right. Where is that bounded? Do I know the min or the max? I know the min, so it's bounded below. Okay, so let's talk about one-to-one. When I do vertical line test, that tells me if it's a function. If I do the horizontal line test, what do you think it tells me? It tells me if it's one-to-one. So when I do a horizontal line through all this, does it hit more than one place? No, therefore, it is one-to-one. Horizontal line test, one-to-one. Okay? All right, what's the next function on your paper? So they, below and yes. All right, what's the next one? 2x plus 3, an easy one. Hit graph. Is it bounded? No. Is it one-to-one? Yes. Look, if I put horizontal lines, do I hit more than one point? No, so it is one-to-one. What's the next function? Absolute value. So you must go to math to get absolute value. It is a type of number. This is not for anti-lock brake system. This is for absolute value. X, what's in the absolute value? X what? Minus 3, and outside of it, plus 5. Okay, bounded above, below, neither. What is it? Bounded below. Is this one one-to-one? No, because right here I can hit more than one point with a horizontal line. Huh? Okay. Last one says what?
Y equals 4 over x squared.
4 divided by x squared. Okay. Okay. Is it bounded?
No.
Bounded below by an asymptote. Right? Right? It's bounded because it gets stopped by an asymptote. Is it one-to-one? No. Okay, that is the review. Good job, guys.